Laser engraving with Snapmaker Rotary module allows you to cut or engrave exquisite patterns on curved materials, making it possible to create multi-dimensional projects. In this video, we're going to show you how to laser engrave with the Rotary module on a paper jar. It covers the usage of chuck and tailstock, and the whole process of laser engraving with Rotary module, including calibrating focal length, generating G-code, setting work origin, starting engraving, and removing finished work. Before we start, you need to prepare the following tools and materials: a vernier caliper or ruler, screwdriver with H2.5 bit, USB flash drive, a pair of laser safety goggles, as well as the chuck wrenches and a paper jar that come with the Rotary module. If you need to calibrate the focal length, you should grab another paper jar, or any other cylindrical material for calibration, as long as it can be engraved. Measure the length and diameter of the calibration material for subsequent input with an accuracy of 0.1 millimeters. In order to avoid looseness between the lid and the body during laser engraving, it is recommended to remove the lid and operate on the body only. Measure the length and bottom diameter of the body. Record the results as well. First, make sure the machine is powered off. Install the laser engraving module and CNC carving platform on the machine, following our quick start guide. Choose the appropriate location on the base to attach the rotary headstock, and use 4 M4x8 hex socket head screws to fix them together from the bottom of the base. Attach the base along with rotary headstock to the middle of the CNC carving platform with 10 M4x14 hex socket head screws. Connect the cable for Rotary module to the add-on 2 port on the controller from behind the Z-axis. Let's first take a look at the chuck and the tailstock, so that you can decide how to use the chuck as well as whether to use the tailstock. If you have already fully understood the usage of the chuck, you can skip this part. The 3-jaw chuck can support materials with various sizes and do inward and outward clamping. The inward clamping is more adaptable to the material shape, but diameter of the material should be no more than 60 millimeters. Outward clamping can be used to secure tubular materials, supporting a maximum diameter of 136 millimeters. But do pay attention to the inside diameter, which should be between 20 millimeters and 100 millimeters. The tailstock can hold objects securely in place. You can adjust the tailstock center to fit the size of the material. For laser engraving, the pressure from the Z-axis on the material is negligible. So, if the material's length or weight will not affect its stability, you can go without the tailstock. Use one chuck wrench to hold the chuck, and the other to loosen the scroll plate counterclockwise. Caution the sharp jaws. Do not turn the scroll plate without wrenches. Insert one end of the material onto the 3-step jaws, and make sure it is coaxial with the chuck. Turn the scroll plate clockwise to tighten the chuck. Be careful not to tighten the jaws too much, or it may cause damage to the material. If the material requires a switch to outward clamping, keep loosening the jaws one by one until they can be removed from the channels. Then insert the jaws back into the channels clockwise in the order of 1, 2, 3. And turn the chuck clockwise using chuck wrenches till the spiral inside the chuck engages the teeth of the jaws. Continue to tighten the jaws. If the jaws close up together, the installation is successful. To switch back to the inward clamping, the insertion sequence of the jaws should be 3, 2, 1. Now, let's get down to business. To use laser function with the Rotary module, first, turn on the machine and upgrade the firmware. Firmwares above version 1.9.0 can be upgraded to version 1.12.0 or above on the touchscreen via Wi-Fi. Go to Settings. Select Firmware Update. Check for updates. Update now, Complete. Follow the guide to calibrate the focal length manually. Input the measured length and diameter of the calibration material. Tap Next. Fix the calibration material to the chuck. Tap Next. Adjust the height of Z-axis on the touchscreen and set the X-Y offsets if necessary. Carefully lower the laser module till it sits right above the material and slightly touches the surface. Tap Next. Now, make sure you and any viewers have put on your laser safety goggles. And tap Next. Set the X-Y offsets to adjust the work origin for calibration. You may also rotate the material by setting the B offset. Tap Set Work Origin, Run Boundary to check the working region. If the tool head bumps into the machine, turn off the machine immediately, or press the emergency stop button. Tap Next to confirm that the working region for calibration is applicable, and tap Start. The machine will engrave a set of lines with slightly different height. Pick the thinnest line that represents an optimal height. Slide to choose the thinnest line on the touchscreen and tap Save to complete calibration. But the guide will only pop up the first time the firmware is updated. After a successful calibration, the height of B-axis will be remembered, so you won't need to recalibrate when laser engraving again. Still, if you have reassembled the tool head, changed relevant parts, or the engraving result is not ideal, it is recommended to recalibrate. You can re-access the instructions by going to Settings, Guides. In addition, you can also recalibrate by tapping Calibration in Apple's screen. After successfully calibrating the focal length, remove the calibration material. Upgrade Snapmaker Luban to version 3.14.0 or above. And go to Laser G-Code Generator. Access the case library, find the test file, and tap Load. In Job Type, input the measured length and diameter of the engraving material. The canvas in the software represents the side spread area of the cylindrical material, within which you should put your model and adjust the size, orientation, and position of it. Note that the highlighted part represents the actual clamping area of the jaws. To avoid the tool head bumping into the jaws, do not place your model beyond that area. Use the default parameters in Configurations and click Process. Use the default parameters in Configurations and tick Auto Toolpath Preview to preview the finished work. Click Generate G-Code and Export G-Code to File to save the G-Code file to your USB drive. Setting the work origin helps the machine find out how to engrave on the material. The work origin in the process of laser engraving is shown in the figure. Insert your USB into the controller. Tap Start, USB to select the G-Code file and USB drive. Preview the file and tap Ready. Select Auto Mode or Manual Mode to set the work origin. Under the Auto Mode, these instructions will walk you through the settings. Tap Run Boundary to preview the working region, and you can reset the work origin and run boundary again if the area is not ideal. Tap Start to begin laser engraving. Use chuck wrenches to remove the finished work when the engraving is done. For CNC carving with the Rotary module, please continue to watch our video tutorial, How to use CNC function with Rotary module. Thank you for watching.